Okay, chapter 4 is all about graphing trig functions. So we're going to take our unit circle and we're going to graph all 6 trig functions from our unit circle. All right, so we're going to take our graphing papers, and hopefully it's helpful to have 2 different colored pens because we're going to do that, a calculator, and our unit circle. So remember from our unit circle that, let's start with sine. So sine is our y coordinates. So I'm going to plot all of my y coordinates around my unit circle here. Okay, so kind of keep that maybe off to the side here and look at it. So when I start at sine, the sine of 0 is 0. And so I'm going to plot that on my axis. And then I go to pi over 6, and pi over 6 is a half. And if I write that as a decimal, it's 0.5. And I'm going to plot it. And then pi over 4 is root 2 over 2. And so as a decimal, if I put that in my calculator, I get 0.7. And then pi over 3 is root 3 over 2. Put it in my calculator, and I get 0.9, 0.866, so 0.9. Let's just go to a 10. And then on my circle, sine of pi over 2 is 1. And then I'm going to keep going. So sine of 2 pi over 3 is root 3 over 2. Put that in our calculator, so we found it's 0.9. 3 pi over 4 is root 2 over 2. We already put that in our calculator, so 0.7. 5 pi over 6 is a half, so 0.5. Pi is 0. 7 pi over 6, negative 1/2, so negative 0.5. 5 pi over 4 is negative root 2 over 2, so negative 0.7. 4 pi over 3 is negative root 3 over 2, so negative 0.9. 3 pi over 2 is negative 1. Pi over 3 is negative root 3 over 2, so negative 0.9. 7 pi over 4 is negative root 2 over 2, so negative 0.7. 11 pi over 6 is negative 1/2, so negative 0.5. And then back to 2 pi is 0. Okay, so now I'm just going to kind of connect them with a general smooth shape. Now remember, we can go around this circle as many times as we want. So these guys continue to go and go and go forever and ever. So we're just going to continue them and give them the shape. So there's sine. That's what sine looks like when we graph him on the coordinate plane. Okay, now cosecant. Remember, cosecant is its reciprocal. Okay, so then I can take these guys and I can flip them over. All right, so cosecant, we can do their reciprocals. If I have a reciprocal of 0, this guy is undefined. And then when I graph undefined, I get an asymptote. And remember, asymptotes are lines that we get closer and closer and closer to, but we never touch. Okay, pi over 6, flip that guy over, so it's 2. When I flip that guy over, I get 2 over root 2. And really that ends up being 2 root 2 over 2, or root 2, which if I put it in my calculator, is 1.4. 1.4. over root 3 becomes 2 root 3 over 3. Put it in my calculator. 1.2. Flip over 1. Reciprocal of 1 is still 1. 2 pi over 3. That gives me that 2 root 3 over 3, or 1.2, sorry. Flip that guy over, that's where we get the root 2, which is 1.4. 5 pi over 6, flip it over, I get 2. Reciprocal of 0 is undefined. So I get another asymptote. Notice I'm getting asymptotes where sine crosses the x-axis. That's going to be important. 7 pi over 6. Flip it over, I get negative 2. 5 pi over 4, I get negative root 2, or negative 1.4. 4 pi over 3, I get negative 2 root 3 over 3, which is negative 1.2. 3 pi over 2, flip it over, I get negative 1. 5 pi over 3, I get, again, negative 2 root 3 over 3, negative 1.2. 7 pi over 4, negative root 2, or negative 1.4. 11 pi over 6, negative 2. And 2 pi, back to undefined. Another asymptote. Okay, so now I'm going to give these guys a curve shape. So, cosecant gives you these two U-shaped or parabola-shaped graphs. Okay, so there's sine and cosecant. Guess what? We get to do this with cosine and secant, and then we'll do it with tangent and cotangent. Right. So here we go. Another graph paper. This time let's do cosine and secant. Okay, this time when we go around our circle, remember we're going to be looking at our x-coordinates. Okay, we should still get the same numbers, just in a different pattern. Remember that? Okay, so 0. Cosine is 1. And then root 3 over 2. And then before we decided that was 0.9. And then root 2 over 2. Which we decided was 0.7. And then 1/2. So 5. Root 2 over 3 is 0. Or sorry, pi over 2 is 0. 2 pi over 3 is negative 1/2. So negative 0.5. 3 pi over 4. Negative root 2 over 2, so negative 0.7. 5 pi over 6, negative root 3 over 2, which is negative 0.9. Pi is negative 1. Okay, still going. 7 pi over 6, negative root 3 over 2. You should see a pattern. 5 pi over 4, negative root 2 over 2, so negative 0.7. 4 pi over 3, negative 1/2. 3 pi over 2 is 0. 5 pi over 3, positive 1/2. 7 pi over 4 root 2 over 2, so 0.7. 11 pi over 6 is root 3 over 2, so 0.9. Back to 2 pi, which is 1. Okay, so we should look like that, and I'm going to give him a general curved shape. Now remember, like I said, we can go around this guy as many times as we want. Okay, missed him there, but that's okay. He should have the same kind of shape that we did with sine, so we should look something like that. Okay, now we're going to do secant. So again, we're going to take the reciprocal of these guys. All right, so secant. Reciprocal of 1 is 1. Reciprocal of that would be 2 root 3 over 3, which we decided before when we did cosecant was 1.2. And then pi over 4 is root 2, which is 1.4. Flip that guy over, which is 2. Pi over 2, undefined. Remember what we said before, when it crosses the x-axis, our reciprocal has an asymptote. So this guy's kind of doing like this. Okay, 2 pi over 3 would be negative 2. Pi over 4 would be a negative root 2. So negative 1.4. 5 pi over 6, negative 2 root 3 over 3, or negative 1.2. Pi is negative 1. 7 pi over 6. Negative 2 root 3 over 3, negative 1.2. Negative root 2 is 5 pi over 4, so negative 1.4. 4 pi over 3 is negative 2. 3 pi over 2, undefined. Again, that guy's crossed the x-axis. 5 pi over 3 is 2. 7 pi over 4 is root 2. So 1.4. Sorry. 2 root 3 over 3 is 11 pi over 6, so 1.2. And then 2 pi is back to 1. Okay, so I'm going to draw in my shapes. Remember, it doesn't cross your asymptotes, just gets closer and closer and closer to it. So there's what cosine and secant look like. All right, 2 more graphs to go. We've graphed 4 of our 6 trig functions. Now we're going to graph tangent. Okay, tangent. Remember, tangent is sine divided by cosine, or y divided by x. Okay, so we're going to still use this guy. We're going to take our y, and we're going to divide it by x, going around our circle. Okay, so here we go. 0 over 1 is 0. And then 1/2 over root 3 over 2. Remember, the 2's cancel. So this is 1 over root 3, or root 3 over 3. And let's put that guy as a decimal. Points 6. Root 2 over 2 over root 2 over 2, that guy gives me 1. Pi over 3, that would be root 3 over 2 over 1 over 2, so just root 3. Again, I'm going to put that in my calculator. 1 1.7. Pi over 2, 1 over 0 is undefined. So I have an asymptote. 2 pi over 3, that guy over that guy, so I'm going to get a negative root 3. Or a negative 1.7. Three pi over 4 is negative 1. 5 pi over 6 is negative root 3 over 3. So negative 0.6. Pi. 0 over 1 is 0. 7 pi over 6. They're both negative, so now this guy is going to be root 3 over 3. Positive 0.6. Negative and a negative is a positive, so 5 pi over 4 is 1. 4 pi over 3, that gives me a positive root 3. Sorry. So 1.7. 3 pi over 2, negative 1 over 0. So undefined. Another asymptote. 5 pi over 3 gives me a negative root 3, so negative 1.7. 7 pi over 4 gives me a negative 1. 11 pi over 6 gives me a negative root 3 over 3, so negative 0.6. And 2 pi, I'm back to 0. Okay. It's a little hard to tell, so there's what your chart should look like. And when you draw them, remember it kind of looks like they're aiming towards your asymptotes, but really what it's doing is it's kind of going like this. So this guy's crossing in the middle here. It's not headed straight for it, and it's going up like that. Okay, there's tangent, so now we have to flip it over to do cotangent. Alright, so cotangent. Take these guys and I'm going to flip them over, so the guy's undefined. Flip that guy over, so I just get root 3, which is 1.7. Flip that guy over, which is 1. Flip that guy over, which is root 3 over 3, which is 0.6. Remember, undefined is that, so when I flip him over, it's reciprocal of 0. 2 pi over 3, I get negative root 3 over 3, so negative 0.6. 3 pi over 4 is negative 1. 5 pi over 6 is negative root 3, so negative 1.7. Pi then would be undefined. I should graph these ones. So undefined is an asymptote. 1.7, 1.6, 0. Negative 0.6, negative 1, negative 1.7, asymptote. Seven pi over 6, that would be root 3, so 1.7. 5 pi over 4 is 1. 4 pi over 3 is root 3 over 3, which is 0.6. You should see the pattern. It's starting to repeat. 3 pi over 2 is 0. 5 pi over 3 is negative root 3 over 3, which is negative 0.6. 7 pi over 4 is negative 1. 11 pi over 6 is negative root 3, which is a negative 1.7. And 2 pi back to undefined. Okay, so there's your chart. I'm going to go plot those last half points. So I would do up to pi. So I'm at 1.7, 1.6, 0, negative 0.6, negative 1.7. Okay, and again, these guys make a curve shape. It's not like a straight line headed straight for them. So they kind of curve down like this. Oops, missed that one. Curve down like that. So that pink there is cotangent. Okay, so you should have all 6 graphs on your paper. Okay? All right, so now let's go look at your notes page so we can fill in the notes and then use these graphs when we're doing our homework. All right. So, a few definitions to start off the 4-1 notes. So, amplitude says if the greatest value of y is m and the smallest is lowercase m, sorry about that. Then we have a formula, and it says amplitude is equal to 1/2 the absolute value of capital M minus lowercase m. Okay, now, what is that saying? Let's look at just a graph. Okay, what that's saying is that the biggest value, if I just look at my sine function, the biggest value that m gets right there is 1, right? Its greatest y value is 1. The smallest y value it gets here is negative 1. Okay, so 1 minus the negative 1 is 2, but half of it, that means this is my amplitude. Okay? Now, there's only 2 graphs that have an amplitude. Okay? Look at the pink graph there. That guy has no big value. It goes on forever and ever and ever. This guy has no small value. He goes on forever and ever and ever. So this guy doesn't have an amplitude. Cosecant doesn't have an amplitude because he doesn't have a true maximum or minimum value. Okay? So, the only 2 functions that have an amplitude are sine and cosine. Okay? Here's cosine, so you can see that. There's my biggest value. There's my smallest value. So my amplitude is half of the distance between the 2 of them. Look at tangent and cotangent. There's no maximum or minimum value, so I can't do that. Okay? The period is the positive value when the graph returns to its starting point. When does the graph start over? Okay, so let's look at sine. Okay, so my graph starts here. It goes here, but it's not actually starting over until it gets back here to 2 pi. So the period for this guy would be 2 pi, right? When does cosine get back to its starting spot? Same thing, 2 pi. Okay, well, let's look at this guy. Maybe you look at cotangent, the pink one. Okay, so my graph of cotangent does this. When does it go back to its starting spot? Right up here, so its period is pi. Okay? Domain. Domains are when we're talking about our x's. So that's your real number value for x. The range is your real number value for y. Asymptotes. We talked about these. So asymptotes are where the functions are undefined for the y values. An even function. An even function happens when you plug in a negative x value and you get your original function out. Okay? These guys are symmetric about the y-axis. Remember that cosine is an even function. An odd function, when I plug in a negative, the negative comes out front. It's symmetric about the origin. Remember that sine is an odd function. Sines matter to sine, right? SIGNs matter to SINE. Okay, so let's look at that for a second. So it says even function. An even function, cosine. It's symmetric about the y-axis, meaning that if I were to flip this guy over my y-axis, it would continue to go on this way. That's correct. When it's symmetric about the origin, remember that means if you kind of do this jazz to it. Okay? So symmetric about the origin, it would shoot down this way and go that way. Okay. So it says, use your tables. Find all values for x between 0 and 2 pi for which the sine of x is a half. Okay, so here we go. I'm going to look at my table, and I'm just going to look for a half between 0 and 2 pi. So here's sine. Got my sine chart. I'm looking for a half. There's one right there, pi over 6. Okay, I'm going to find another one, 1/2, and 5 pi over 6. Then it says show that cosecant is an odd function. Okay, well, cosecant. If I plug a negative angle in for cosecant, that would be the same as if I did that guy. And remember, sines matter to sine. So I'm going to pull that negative one out front. So that negative becomes cosecant. Okay. So number 3 there says use the odd and even function relationships to find the exact values for each. So instead of going to negative 2 pi over 3, I know that cosine is an even function, so I can just go to the positive one. So cosine of positive 2 pi over 3. So 2 pi over 3, if I look at my circle, cosine of 2 pi over 3, or I can also use my charts that we just made because we have both on there. 2 pi over 3 is right there. So he's negative 1/2. Cosecant of negative 225. Well, we just determined that cosecant is an odd function. So this guy is the same as the negative cosecant of positive 225. And 225 on my circle is 5 pi over 4. Pi over 4 is right there. So this guy is negative root 2. So root 2. Oops. Alrighty. That was your introduction to graphing, and now we've got all 6 graphs.